Hello everyone, my name is Alexis Flores and I am a technical marketing engineer here at Cisco. The purpose of this video is to go over how to configure high availability on the Cisco Catalyst 8000V Edge software deployed in AWS Cloud. Before we start things off, let's first talk about what is high availability and why we need it in today's modern growing cloud infrastructure. As businesses continue to migrate their critical on-prem workloads to the public cloud, they need the reassurance that their business-critical workloads are accessible and protected at any given time. They can protect their workloads with seamless failover in the cloud by using a pair of Catalyst 8000V Edge software and high availability, which is available across all major public cloud providers. If you're not familiar with high availability is used to establish redundancy of network functionality between two nodes. And in this video, we'll be using a pair of Cisco Catalyst 8000V for our examples. High availability, or HA for short, in the public cloud behaves a little differently in comparison to traditional on-premise deployments due to the limitations in multicast support and layer 2 packets, and we'll talk more about that on the next slide. As just mentioned, cloud providers don't allow multicast or broadcast traffic, so we can't use a virtual IP as in with HSRP. But what we can do instead is configure bidirectional forwarding detection, or BFD, over an IPsec tunnel between the pair of c8KVs to detect failure between each node. Once HA is configured on the c8KV, it will detect failure automatically and will call the cloud provider's REST API, in this case AWS, and shift the route table's routes to the surviving or standby c8KV, and the same applies if we configure recovery for the primary c8KV. HA in the Catalyst 8000V is cloud agnostic, meaning that it can be deployed on any supported public cloud. It has fault recovery and supports customizable user scripts for your cloud environment. Now let's go over a typical HA deployment scenario to get a high-level overview of how HA works on the c8000V when failover is detected in AWS. So in this deployment scenario, we have a customer who has recently migrated their business-critical workloads to AWS. They have a corporate branch, and they've decided that they want to protect their business-critical workload by deploying a pair of c8KV in HA for its fast failover while also taking advantage of the performance that comes with the c8KV. Here in this topology, c8KV1 is set up as the active router in the application VPC, shown with the green ring around it, while c8KV2 is the standby router, as shown here with the gray ring. The business-critical traffic travels from the edge router in the branch location through the active c8KV in the application VPC to where the critical workload servers are located, and this traffic is secured using IPsec tunnels between these two locations. Now let's say that there was an outage in the availability zone where c8KV1 is located and c8KV1 goes offline. c8KV2 will detect the failure using the BFD protocol by sending 3 packets and wait for c8KV1 to reply. If there's no response, then the standby c8KV2 will execute the HA script and assume role of the active router, and here in the diagram is depicted with the green ring around it. When c8KV2 executes the HA script, it will go ahead and send an HTTP request to the AWS REST API, and AWS will go ahead and update the route table in our application VPC or subnet to the IP address of c8KV2. Now, network packets from the critical business workloads are now redirected to c8KV2 and will act as the active router until c8KV1 comes back online. Now, let's say that once the power is restored to this availability zone and c8KV1 comes back online, the BFD tunnel will be reestablished between c8KV1 and c8KV2. Afterwards, c8KV2 will go ahead and revert back as the standby router, while c8KV1 recovers back to being the active router. And then when this happens, c8KV1 will go ahead and execute the HA script and will make a call to the AWS REST API, and AWS will update the route table once again in our application subnet to the IP address of c8KV1. And you can see that on the top where the blue rectangle is. And then once the route table is updated again, traffic will return back to its original path with minimal interruption. Now that we've gone through a high-level overview of how a pair of c8KV and HA work in the AWS cloud, now let's go ahead and take a look at the configurations needed to set up HA on the c8KV itself. So configuring high availability on the c8KV can be done in 5 easy steps. First thing we're going to do is go ahead and configure the guest shell. Afterwards, we'll go ahead and configure the routing and BFD tunneling between the active and standby c8KVs. And then we'll go ahead and download and install the HA package for AWS. There's different packages for different cloud service providers, but in this video, we're only going to be focusing on the HA package for AWS. Once we do that, we'll allow the active and backup routers to make changes to the AWS network by creating an IAM role and attaching it to the EC2 instances. And then we'll go ahead and run the HA scripts and create an HA redundancy node between the two c8KVs. And then these commands will be applicable to both the active and standby routers, so don't forget to apply these to both of them. So here's a summary of the list of commands that we will need to run on each of our c8KVs. First, we're going to go ahead and enable the guest shell so that we can go ahead and download and configure the HA script. After enabling the guest shell, we can create an IPsec tunnel between the active and standby c8KVs. There are multiple ways that you can create an IPsec tunnel. Here in this example, I have just set up a basic static IPsec tunnel, but you're free to use any additional configurations however you see fit. And one thing that I want to point out is that when we configure the tunnel interfaces, we can set our BFD interval to send packets as fast as every 50 milliseconds and onwards. Here in this line under the load interval 30, here it's stating that we want this tunnel interface to transmit a BFD message every 100 milliseconds and also listen to incoming BFD messages every 100 milliseconds and to wait for at least 3 BFD packets before assuming that the peer has failed and has gone offline. The BFD timer will expire and trigger a peer adjacency down event and will cause the HA script to execute. And then we can enable BFD on all our interfaces inside of our routing protocol, and you don't have to use EIGRP, but please refer to the documentation for a full list of supported routing protocols for HA. After configuring the BFD, we can go ahead and download the HA script using the guest shell. And in this case, we're deploying in AWS, so we'll be installing the CSR_AWS_HA. And don't forget the user flag here, the -- user. And we'll be using pip3 to install the Python package. After configuring the IPsec tunnels, the BFD forwarding, and installing the HA script, if you want to let the c8KV routers update the route table in the AWS network when a failover is detected, you first have to authenticate the router and give it permissions to update the resources in the AWS VPC. In the AIM management console, create a policy that permits the c8KV router to access the route table. The c8000V HA documentation gives us a sample policy that we can use to give to the router permission to make these changes. You can use that or create your own, but it must have the permissions shown here as a minimum requirement. Otherwise, the routers won't be able to make the changes to the route table and you'll lose access to your VPC if the active router fails. And then after you go ahead and create this IAM role, which is created using the policy, apply it to both of the EC2 instances, such as the active and the standby c8KV. So once we went ahead and configured the IAM role and attached it to our EC2 instances, we can go ahead and run the HA script or configure the HA script that we downloaded in the previous step. And there are a few things that we're going to need in order to run the HA script, and that is the node index, the region name, the route table name, and the next hop interface name. And in this example, here you can see the active and standby c8KV along with the attached interface that is attached to our route table 624. And we're going to run similar commands on both the active and standby router. Here we're going to use the create node py. This is the actual command that is going to go ahead and create the availability script and run in the background. And what we're going to do here is just going to go over what this command does and what the flags mean. And for example, in the active router config, here I'm passing a node index of 100. This number can be whatever you want. Here I'm using node index 100 for both the active and standby router. And then the -t, we're going to go ahead and pass in the route table that we want to change. So whenever the HA script is executed, it's going to go ahead and make a change to route table 624. And here I have the route table that ends in 624. Note that you want to pass in the route table ID and not the name of the route table, because sometimes you can give it its own name, but here we need the ID specifically. And you can find the ID on your VPC route tables. It should have the ID when you click on the specific route table that you want to look at. And then you want to pass in -rg, which is just the region name where your deployments are located. In my example, mine are located in US East 1, so I'm going to pass that in. And then -n, this is the interface that we want to be the new target on our route table whenever the script gets executed. So here we're saying that whenever the active c8KV executes the HA script to the route table 624, I want the new target to be ENI 767, so that whenever traffic flows back, it's going to go through the route table and go through the active one instead of the standby one once again. And here we can use -m primary or secondary. Here we want to use this in case that if when c8KV1 comes back online, if we want it to revert back as the primary node, or if we want traffic to go back to the original one, then we can pass in a primary and then pass in secondary for the standby one. So whenever c8KV1 does go down and comes back up, then we can just revert back to the original path and change the route table back to the original ENI, which in our case here is 767. And then so that's pretty much all you're going to need to configure for the script. The standby router will be exactly the same, except you'll just change the ENI to the interface on the standby router. And of course, if you want this to be the secondary node, then you want to push a -m secondary. And there are some additional commands here that you can use. Here we can use clear parameters to change or to clear the configuration that we currently have attached. Here we're erasing the node index, we're erasing the route table, the region, the interface card, and then the mode that it's in. And if we wanted to see what configuration we currently have on our script, we can just use the show_node.py and just give it the node index. And then this last one here, node event here, this will generate a log and show you what would happen if the script executed, just to verify that it's what you want it to do. And if you wanted more information on the scripts and how it works, then you can go ahead and go to this link here, ces.co/c8KV-HA-AWS, and this will take you to our documentation where you can find more information on HA deployments for c8KV. So now that we've gone over the configurations, I just wanted to show you how it looks like once configured on the C8000V. So I've already deployed the active and standby router and have configured the IPsec tunnels. I'm not going to go over how to configure IPsec tunnels. There's a bunch of videos on YouTube on how to do that. But I wanted to focus more on how it looks like once you have the IPsec tunnels configured, and then how to configure the actual HA script afterwards. So here I've ran a show IP interface brief to show that here I have two tunnels. I have one tunnel up and running to my standby c8KV from the active to standby. And this tunnel 2 is a secondary tunnel that's running from my branch location router to the active c8KV, as shown in the sample topology I mentioned in the earlier slides. And then so after configuring the tunnel, I wanted to show you here, I've configured a tunnel interface with the BFD interval of 100 milliseconds. So it'll send BFD messages every 100 milliseconds and then listen to them every 100 milliseconds and then wait for 3 messages. It'll send 3 at a time. And afterwards, I also shown here I've configured EIGRP on my router as my routing protocol, and here I've enabled BFD on all interfaces, and I've shared the tunnel network with the other peers. And then also wanted to show you that I've also enabled the redundancy. So here I'm saying enable cloud redundancy with the cloud-HA with BFD, and have my peer be this address, which is the IP address of the c8KV that is on standby, or c8KV2 from the example previously. So now that we've gone over the tunneling, now what we want to do is go ahead and enable the guest shell interface. So what I want to do is go ahead and run guest shell enable, and then this will enable the guest shell on our c8KV. I already had this running previously, so you'll either get a guest shell enabled successfully output, or you'll see that it'll start running in the background and complete once it's ready. So once you have the guest shell, you'll see something similar. So now that we've enabled our guest shell, what we can do now is go ahead and install our high availability script or package from the repository. So first thing I'm going to do is go ahead and go into the guest shell. Might take some time, but it should show you a guest shell at guest shell command. So now that we're at the guest show, what we can do now is go ahead and install the HA package for AWS. And here we can use pip3 install csr underscore AWS underscore HA, and don't forget the -- user flag. And when you press enter, it'll go ahead and start downloading it. But I already have this downloaded just as to save time. So that's why it says already satisfied. But you will see it go through the install process, and then to verify, you can do an ls, and you should see a cloud folder there. You can navigate to the content, see what's in there, look at the scripts and how they look like, and you can do that on your free time if you're curious about how it looks. So after we install our package, I went ahead and navigated over to our IAM configurations, and as mentioned previously, we're going to need to create an IAM role and attach it to our c8KVs for both the active and standby ones in order to be able to make changes to the route tables in the VPC. So here I've went ahead and created a role name called c8KV HA IAM role, and if we click on it, here we can see the definition of what's inside the policy. And as showed in the slides, I pretty much copy and pasted the information that's available on the configuration guide and added that policy into this role. And then we can go ahead and make sure that it could, be able to create routes, edit the routes, change the routes, and create logs about the routes. And once we have this configured, or we have this IAM role set up ready to go, we can go ahead and go into our EC2 instance on both the active and standby c8KVs. And here I'm looking at my c8KV, active c8KV right here. And I'm going to go ahead and attach this role to the EC2 instance, so it should be able to make changes to the route table whenever the HA script gets executed. So I'll go ahead and click on that role, and then I'll go ahead and click on Update IAM role. I already have this role on it, so it should not be an issue. So once we have this, then we can go ahead and run the HA script. So whenever it gets executed, it should be able to access these route tables that we gave it access to. So once we have the IAM role configured and attached to our EC2 instances on both the active and standby c8KVs, we can actually go ahead and run the HA script and attach them to our c8KVs. So as mentioned before, we're going to go ahead and run the create node.py command. We're going to pass a node of 100 just for this example. You can use any number for the index number. And I'm going to pass in the route table 624, which if we go back and look at our route tables, I can go ahead and go to my VPC, and then I can go ahead and go to my route tables. And then here, if I look at my private route table, this is the one that was associated on the VPC. So if I look here to details, or if you look at the number here, if we can see the ID of the route table. So I'm passing in this one. And as you can see here, currently on the routes, our current target is the ENI ending in 767, which is the active one in the topology. So now going back here, I'm passing in the route table ID. I'm working in US East 1, so this is the region I'll be passing in. And whenever this gets executed from the active c8KV, I wanted the target to be this interface, which ends in 767, as you saw previously. And if we want this to revert back as the original or primary c8KV, we'll just pass it in the -m primary flag to make sure that it comes back online and takes back ownership once it is back online. And then when I press enter, here it'll show you a 200 command, meaning that it executed successfully. It said all inputs are valid, and then that the node has been updated successfully. So now if you wanted to verify that the commands were entered correctly, or if you just wanted to check that you have the right configuration, we can go ahead and run the show_node.py command and pass in -i100, which is just passing the node index. And then this will return the information that you entered when you were executing the create node command. And here you'll see that the index is 100, the route table ID that we're going to change is 624, the region it's operating in is US East 1, the ENI that will be the new target is 676 whenever the HA script gets executed, and then the mode, this is set as the primary node. So like I said earlier, it'll become the primary, or it will revert back to the active one once it's back online. So now that we've configured the active c8KV successfully, we can do the exact same thing on the standby c8KV. The commands will be exactly the same, except The only thing we're going to change is the target interface on the create node script. So this interface is currently facing the primary one. You'll just change this to the one facing on the standby c8KV, and then you would also change the mode to secondary in case you want to configure a primary and secondary node for your HA deployment. So after configuring the active c8KV, I went ahead and did the exact same configuration to the standby c8KV as well. And once I have those two configured, then I can go ahead and actually start simulating a failover. And we can do that by first, I'm going to start generating some traffic from our branch location to our application VPC where our critical workloads are located. So here I started a continuous ping from the branch to the application VPC. And I can simulate a failover by reloading the active c8KV. And then let's see what happens to the standby router once it detects that its failure is down. So I can do this by doing a reload. So now that it's been reloaded, let's see how the c8KV2 behaves. And if you look here, we can see that it went ahead and noticed that its neighbor is down. So as you can see here, it sent three messages. And you can see here that the timer expired, meaning that it sent 3 messages, it didn't get anything back, it assumed that its peer went down. And if we look here to the shell exec command async, here is the node event. Here is the script that ran saying, oh, our peer is down. Let's go ahead and write to the AWS route table saying that c8KV2 or the standby one is the new router to point to. And if we look to our pings here, we can see that we still have a continuous ping, meaning that we may have lost a packet or two in the transition. If we go ahead and look at our VPC route table, here initially it showed as the route table 767, which is pointing to our active c8KV. And if I press reload or refresh here, and I go back to our VPC route table that we changed, and if I go to routes here, you'll see that now its target is pointing to 705B, which if I click on this interface here, it should show me that this is pointing currently to the standby IP address. So this is the IP address of c8KV2, which is our standby in our HA configuration, meaning that the change was made successfully and now it is currently pointing at c8KV2. And then once c8KV1 or the active router comes back online, it will change the route table back to the interface on the active one. And that's pretty much it. That's all it takes to configure high availability in AWS using a pair of C8000V. Hope you guys enjoyed this video. Please subscribe and I'll see you on the next one.